Okay, first video on chapter 20. So we're still doing significance tests. This first video will start to talk about putting a value behind how small p-value would be and how large a p-value would be. So there is no rule for how small a p-value we should require in order to reject a null hypothesis. It's a matter of judgment, and it really would depend on the circumstances of the problem. We can compare the p-value with a fixed value that we regard as decisive. We're going to call that our significance level. We write it as our Greek letter alpha. When our p-value is less than a chosen alpha, we say that the result is statistically significant. In that case, we reject the null hypothesis and conclude that there is convincing evidence in favor of the alternative hypothesis. So in general, we can follow the rules that say that when the p-value is less than your alpha, we'll reject our null hypothesis, and if our p-value is greater than or equal to our alpha, we will fail to reject our null hypothesis. So some common significance levels are 1%, 5%, and 10%. So they correspond with alphas of 0.01, 0.05, and 0.1%. 1 for 10%. Just like 95% was our conservative guess in our confidence intervals, if it wasn't specified to us what confidence level to create a confidence interval with, we always use 95%. Similarly, we'll use 5% as a significance level if it is not specified in a problem. So we're just going to run through this one quick problem and be done with this video. So according to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. A news report claims that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for their employees. A random sample of 100 employees finds that 68 answer yes when asked, does work stress have a negative impact on your personal life? Is this good reason to think that the proportion of all employees in this chain who would say yes differs from the 75%? Support your answer with the significance test. So the first thing is that it's not specified at what significance level to carry the test out with, so we will use a significance level of 5% or an alpha of 0.05. So before I run any significance tests, I always have to check to make sure that my conditions are met. Okay. So my first condition is at random. It says that it's a random sample of 100 employees, so we're good there. Our independent condition is definitely met. The sample size is 100, and 100 is definitely less than or equal to 10% of all restaurant workers. Okay, and then finally, our large counts condition. Okay, also met. So you have 100 in the sample, so we're expecting about 75 successes, which is definitely greater than or equal to 10. And then our fails will expect 25. Which is greater than or equal to 10. So because our conditions are met, we can go ahead and run a significance test. So first step is we are going to write our hypotheses. So we'll start with our null. Our null is no change. So we're going to go with their original claim of the 75. Our alternative hypothesis is questioning that 75, and it's actually suggesting that it may be less than the 0.75. Okay, so I'm going to rely on my calculator to help me get my test statistic here. My null hypothesis, so this is just kind of what you would put into your computer screen. Your x value was the 68, your n, there's 100 here, and then you're going to highlight the one that's less than your null hypothesis. Okay, so after putting that into my calculator, I'm going to get a test statistic of negative 1.617. So I'm just going to do a quick sketch so that I can find my p-value using norm CDF. Okay. So negative 1.67, about there. So I'm looking for that space over there. Okay, so I want to find the probability that my proportion will be less than 0.75 if the true proportion is 75%. And so I'm looking for my z to be less than or negative 1.617. So I'm going to norm CDF. Low boundary, upper boundary, and my p-value is going to be, 0.0529. Okay, so now what we know is that we're now going to want to say if we think that this is a very small or a large p-value. Okay, so what we'll do is we'll compare our p-value to our alpha. So my p-value is 0.0529, and my alpha wasn't specified, so we said we would use 5%, so my alpha is 0.05. Your p-value is greater than or equal to your alpha, and so this is going to tell us to fail to reject your null hypothesis. This would suggest that we do not have convincing evidence against our null hypothesis, so we will fail to reject it. And that's it for the first video.